Hey everyone, today we're going to continue doing percent problems, but you're going to have to be a little more careful for these type of problems because they are trying to trick you. So today you are going to read the problem carefully to understand what it is asking for. Let me give you some tips today. So similar to what we did yesterday, you're going to start every percent problem the same, right? Set it up the ratio way. And then that will help you figure out if you're looking for the part, the whole, and the percent. And like we did last lesson, you know the different strategies for the different things you're looking for. Next thing you're going to do is decide what strategy you're going to use to solve the problem. But, and this I maybe should have added it to last lesson slides and lessons, but we're going to talk about it now. You need to make sure you read carefully to make sure you understand exactly what you're looking for. Because sometimes if you just go quickly and do percent over 100, part over a whole, and you just solve it, you actually solved and found the wrong thing. And I'll give you some examples of what I'm talking about today. So something that will help you is to use your variable to help you know what is happening. Let me explain what I mean by that. Here's our first question. 25% of Santa's reindeers were playing reindeer games. How many of Santa's reindeer were not playing games? I am going to see that 25% and I'm going to immediately set that up that way, right? And let's see, how many of Santa's reindeer were not playing? Okay, so how many total reindeer does Santa have? You know, Dasher and Dancer and Donner and Blitzen, Comet and Cupid and Donner and Blitzen. 8, okay? So I know that there are 8 total reindeer. Now, if we were to solve this, which you might be like, oh, I know how to solve this. I know that this is 1/4, and I know this is times by 2. So I know the answer is 2. 2 reindeer. Now, here is the tricky part that I'm talking about. This 25% is how many of Santa's reindeer were playing reindeer games. But that's not what the question is asking. The question is asking how many of Santa's reindeer were not playing reindeer games. So what you could do is you could, right here where you have the unknown, put a variable there. And it says that 25% of Santa's reindeer were playing reindeer games. So maybe I'll put a P there, and that stands for the 25% that were playing. So that way I know that when I find that the answer is 2 reindeer were playing reindeer games, right? That's not my answer yet. To find out now how many of Santa's reindeer were not playing, I can go 8 minus 2 and I can get 6. 6 reindeer were not playing reindeer games. So that's strategy number 1 for that. Let's go back here though, and let me show you a different strategy that might make more sense to you. When we are back to this problem, when we know that 25% is the percent that we're playing, well, we can solve this problem with the percent that we're not playing reindeer games. So if 25% were playing reindeer games, then what is the percent that we're not playing? We know about percents that it always equals 100%. So if we take away the percent that was playing, that's going to leave us with the percent that was not playing. So we could, instead of solving for 25 out of 100, 25%, we can solve for 75%. And then we can be like, oh, hey, I know that's still going to be times 2, but now I get 6. 6 reindeer were not playing reindeer games. Okay, both of those ways work. It's just going to be what makes more sense to you. Okay, so you see how that was pretty tricky? Here's another tricky-ish problem. 90% of the students in class are on Santa's nice list. If there are 30 students in class, how many are on the naughty list? So again, I'm going to solve it those 2 different ways. And I'm going to kind of let you decide what makes more sense to you. So if we start with the 90% out of, there are a total of 30 students. So we're going to put 30 on bottom. Now this 90% is for the students who are on the nice list, correct? So we can solve this. I'm going to do it the ratio way, but you know that you're more than welcome to do it the decimal way. We're going to end up with the same answer. I'm going to get 27. So I know that 27 are on the nice list. Well, then I will just need to subtract the nice from the total to get how many are on the naughty list. Okay, so that's the first strategy. Now the other strategy that I showed you is, okay, if 90% are nice, then what does that mean is the percent for naughty? Well, it's got to be that 10% is naughty to equal 100% of the total people in the class. So I can solve it with the 10% instead. 10% and still 30 total students. That will give me, spoiler alert, the same number. There are 3 naughty kids, 3 students that are on the naughty list. We feeling a little bit better? Okay, so you can see why you need to read carefully, because some of you might just be like, all right, guess what? The answer is 27. There are 27 kids. But those are the ones that are the nice ones. The question asks how many are on the naughty list. So again, read carefully. Sam wrapped 30% of the presents in green wrapping paper and 50% in red wrapping paper and the rest in blue wrapping paper. There are 8 presents. If there were 8 presents wrapped in blue, how many presents were there in all? All right, I know this 8% is the part. It's the part that was blue, right? And the question is, how many were there in all? So I'm going to put a P. We want to know how many presents there were in all. Now here's where I'm a little stuck because I've got all these percents here. Which percent should I use? Well, if I'm going to use the 8 that were wrapped in blue, then I need to stick with the percent that was blue in order to make this ratio make sense. So, but I don't know the percent for blue, do I? But I can figure it out. Okay, let's think about this again. 100% of the presents. 100%. Whenever we have percents, it always equals 100. We know that 50% are red. We know that 30% are green. So we can now figure out the percent that is blue. How are we going to figure that out? Well, 50 plus 30% is 80%. And if I have 100% and I want to figure out what is left over after 80%, then I'm going to subtract it. That tells me that 20% of all of the presents are blue. So I can finish my ratio here and see what I can do. Well, I'm going to stick with blue because it's blue. So let's simplify, see that there's a ratio there, and I'm going to notice that there are 40 total presents. Now, would that make sense? Yeah, if there's 40 total presents all together, it makes sense that 8 of them are blue, and then we have green and red, and that would all equal 40 total presents. So that one was a little tricky because we had to do some work to even get to this part, didn't we? But we're able to. We have all the skills we need to figure that out. Mrs. Madsen and Mrs. Frenzel decided to buy a trampoline for recess. We didn't tell Mrs. McKell. Shh. The price of the trampoline was $400 plus the 6% tax. They decided to split the cost evenly between the two of them. How much did each teacher pay? You can see how this one's a little bit tricky, right? Because it's like Miss Madsen and Mrs. Frenzel are splitting it, and there's tax, and blah, blah, blah. So let's just take it step by step. Let's figure out what the total price of the trampoline is with the tax, and then we can split it evenly. Okay, so I know that it's 6% tax, and I know that the total trampoline is $400. So I'm going to, if you wanted to, you could decimal it up. Okay, just make sure for 6% you scoop twice. Don't make it 60%, make it 6%. I'm going to stick with the ratio way because there's a very clear relationship here. And I'm going to get $24. So add that to the trampoline. And because it's a tax, right, you have to pay extra for the tax. So there's $424 total. Now let's get to the part where they decided to split the costs evenly. There's 2 of us, so we're going to split it 2 ways, and that's going to give me $212 each. You okay with that one? Let's move on then. Is this true or false? 20 is 75% of 30? How in the world? All right, well, Mrs. Madsen says that anytime you see a percent, you can always put it over 100. Okay, and then it says 20 is 75%, so that's the part of 30, so that's your total. So we just got to figure out if this is true or false. How are we going to do that? Here's what I would do. I would get rid of one of these. So if we get rid of this, then let's figure out what that is as a percent. Okay, so that's option 1. Here's another option. Get rid of this and figure out what 75% of 30 is. Okay, that's option 2. Option 3, get rid of the whole and figure out that 20 is 75% of what number. So you get to kind of decide which problem you want to solve. I personally like finding the part. Okay, and that's because I have a few more options. I can do it the decimal way, or if I simplify it, there's not really a relationship, is there? So yeah, I'm gonna have to do it the decimal way. So 5 times 0 is 0, 15, add a 0, 7 times 0 is 0, 7 times 3 is 21. Add it up and I get 22.5. Yeah. So 20 is not 75%, 22.5 is 75% of 30. The other way that we talked about, figuring out what the percent is of 20 to 30, we can simplify that and get 2/3 and be like, oh, hold on, I know what percent that is. That is 66.6, or round that to 67%. So yeah, that wouldn't be true either. We could say that 20 is 67% of 30, and that would be true. Or we could say that 22.5 is 75% of 30. But the way they have it written down is false.